Well, hello everyone. Welcome and thank you for joining us. My name is Ed Tether and I'm your moderator for today's session. I'll touch on what we're going to talk about today, the running order, and introduce our panel in a moment. But first I wanted to hand over to Mike, lead on the Pandemic Resilience Project, for a traditional Maori welcome to help us get started. Over to you, Mike.
Good, thank you. If I could just get the slide up, please. Tēnā tātou e hoana, kua haere mai nei ki te ako, I ngā whakaaro. Ka nui te mihi ato mō tō kotoro arunui. Ki te ara mai I ngā kaupapa o te rā, kua mutu I konei a kua mihi mō te noa. Nō reira, tēnā koto a tēnā tātou katoa. So I just wanted to say that's just to welcome everyone here and open the space where I'm sure is going to be a really interesting conversation. Back to you, Ed.
Thanks, Mike. So it's a real pleasure to be discussing this project today, and I think, to be honest, it's one of our most exciting in GPAI within our overall portfolio. And I think it's an exciting project as it's really leading on where I think we should be taking GPAI's broader agenda. There's collaboration across our working groups, it's partnership between experts and government, and it's got a really practical focus that can move the dial on some of the big challenges we face as the international community. For those who are less familiar with PETs or privacy-enhancing technologies, they're a basket of emerging technologies that could help facilitate cross-border collaboration on data and AI in a way that helps protect important rights, not just privacy, but also sovereignty and intellectual property, among others. And you'll be hearing a bit more from Adi on that shortly. There's still some way to go on these techniques being more broadly adopted. Research suggesting that increasing awareness and understanding of pets and their use cases could foster greater adoption of these technologies. And that's where this project comes in. The Data Governance Working Group has decided to run a practical demonstration that could align with other GPAI work streams. And we've been looking at how this could align with pandemic resilience, climate action, and the future of work. We've been delighted to be collaborating with Singapore, specifically IMDA and the Digital Trust Centre, who have been wonderful partners on this endeavour. And in our first few months, we found a strong match on pandemic resilience, which we'll hear a bit more about in a moment. And the intention, once we've done the practical demonstrations, to share guidance on the responsible adoption of these techniques, drawing from our learnings and consulting with other partners engaged in this work. So I'm very excited to be introducing our panel, who will be telling you more about this project. And we're also very much looking forward to hearing your questions and thoughts. So the first person to introduce on the panel is Mike, who you just heard from for the welcome. Mike is a senior lecturer at the University of Auckland and deputy director of the Complex Systems Centre of Research Excellence. He is the GPAI lead on pandemic resilience, and his research into applying operations research to complex systems spans over 20 years and over 100 publications. He was part of the COVID modelling team in New Zealand that won the Prime Minister's Science Prize in 2020 for supporting New Zealand's response to the COVID pandemic. Next up is Shamik Kundu, and Shamik is Chief Strategy Officer and Head of Financial Services at Churera. Shamik is one of the representatives from Singapore at GPAI, where he's been co-leading our project on privacy-enhancing technologies. Shamik has spent most of his career in driving responsible adoption of data analytics and AI in the financial services industry. He is a member of the Singapore Government's Advisory Council on AI and Data, the Bank of England's AI Public-Private Forum, and the Monetary Authority of Singapore's Steering Committee on Fairness, Ethics, Accountability, and Transparency in AI. Next up is Kim McGrail. Kim is a professor at the University of British Columbia School of Population and Public Health, and the Centre for Health Services and Policy Research. She's also Director of Research for UBC Health and Scientific Director of the Population Data BC and Health Data Research Network Canada. Many hats. She is currently a Canadian representative to GPAI, and alongside Shamik is the co-lead for our PETS project. She's also been a member of the expert working group for the Pan-Canadian Health Data Strategy. Next up is Wan Si Lee, who is a director at IMDA. There's Wan Si. and she's the Director for Development of Data-Driven Tech at Singapore's Info IMDA. In the area of AI, her responsibilities include driving Singapore's approach to AI governance, growing the trustworthy AI ecosystem in Singapore, and collaborating with governments around the world to further the development of responsible AI. She is also responsible for encouraging greater use of emergent data technologies such as privacy-enhancing tech to enable more trusted use and sharing of data in Singapore. And finally, we have Adhiraj Saxena. So Adhiraj has been the point person IMDA for its privacy-enhancing technology initiatives, including this one with GPAI. He's worked for economic agencies in the Singapore Public Service for 12 years, and his background is in data engineering and G2B technology projects. So I think we're ready to begin. So what we're going to do is we're going to have 15 minutes to learn about the use case from Mike, then 10 minutes for a deeper dive on pets and Singapore's approach from Adhiraj, and then we'll have some time for a panel discussion and some questions and answers. So do be thinking of the questions you want to be asking as you listen to these presentations. So with that all said, Mike, over to you.
Me, Ed. If I can get the slides up, I'll get started. Yeah, so today I'm going to talk first about the Pandemic Resilience Project, and the key point for this project was to look at global modelling efforts and try and pull them together to create a streamlined version which can create accurate and transferable models. Next slide, please. So during the pandemic, there was lots of modelling and very good modelling happening, but it was all happening in isolation. So you can see an example here. We've got models created, Model 1 created in location A, and Model 2 created in location B. And those models use parameters that may be global parameters, for example, the transmission rate of the Omicron variant. There may be location parameters, so for example, the effectiveness of mask wearing in Singapore versus New Zealand. And there may be model parameters, for example, the number of layers in a neural net, which might be one of the models. These models also took some data from the locations, so that may be things like the current number of infected individuals, and then go through and they would create outputs which might be predictions of the future number of infected individuals. Those could then be compared to historical data to give you an idea of the model accuracy. So this was done in parallel across multiple different countries throughout the world, and what we wanted to do was to bring a lot of this together. So if you could go to the next slide, please. And one of the key parts of building these models also calibrating them to make sure that they were as accurate as possible in their locations. You can see there the calibration feedback loop where the accuracy of the model would then result in parameters being calibrated. But this is happening in parallel across these different locations. So you may actually have different values for the global parameters, even though they should actually be the same. So if we can go to the next slide, please. And so what we're trying to do in the Pandemic Resilience project is to create standards for those parameters and then enable those to evaluate an ensemble of models. So we want to take these models from across the world, pull them together, make sure that they're using the same parameters for the same, or the same values for the same parameters. So we want a standard set of parameters across all of our locations and all of our models. We want a standard set of parameters for each of our locations. So for instance, a neural net model should be using the same value for mask wearing in Singapore as our stochastic model. And similarly, they should be using the same value for mask wearing in New Zealand. They should all be using the same value for the transmission rate of the Omicron variant. What this then means is that we have multiple models across multiple locations. These models are creating predictions of what's going to happen next. Again, this is often how the pandemic is progressing. That can be compared against the location's outputs, which means we get accuracy of each of the models, but we'll also then have what we call an ensemble accuracy, which means how well is our ensemble of models doing at each of the locations. Can we have the next slide, please? And so now the calibration is a little bit more complex. So we can calibrate each of the model parameters at each of the locations, depending on the model's accuracy. But if we want to calibrate the model parameters, they actually depend on the ensemble location, the ensemble accuracy at the location, because remember we're using the same location parameters across all the models at the location. And then the global parameters get calibrated from the ensemble accuracy from all of our locations, because we're going to use those standard global parameters across all of our models and all of our locations. What this means is we now can use the information we have around all of our locations to get these global parameters right. We can use the information across all of our models to get the location parameters right. So now we've got a much richer number of parameters that we can calibrate to the data, with recognition also that we maybe have a few more parameters than we would have otherwise for the models. Next slide, please. And so the idea with the ensemble and the pandemic resilience is, once we have a calibrated model, we can then use that in new locations. And it was around this time, as we were building up the idea of this transferable model, that PETS came along. And so the main idea with how PETS is applied to the pandemic modeling is we want to somewhat accurately model the pandemic response, but we also want to preserve data privacy. So we can go to the next slide. I'll explain a little bit about how that would work. Next slide, please. So you consider the social dynamics that happen with a pandemic. So it might be that person A1 and person B1 work in the same workplace, and person A2 and person B2 interact in the same community. So whether that's cafe, shopping, petrol station, etc. That's what happens during the day. And then at night, person A1 and person A2 are in the same household, and similarly for person B1 and B2. And so if we move to the next slide, we'll see what that means in terms of interactions and COVID spread. Next slide, please. So what that means is there's a transmission rate, and maybe it's quite high between A1 and B1 because they work closely together in the workplace, and similarly quite high in both the households, but maybe less, so there's less transmission within the community. So maybe it's about a quarter of the usual transmission rate, R0. So that means we know we have during the day transmission, which is high between A1 and B1, and less high between A2 and B2, and during the evening transmission, which is high between A1 and A2, and high between B1 and B2. So can we move to the next slide, please? This means you get a transmission rate matrix that looks as follows. And you notice a lot of this halved. I'm assuming here that you spend half your time in the daytime configuration, half your time in the nighttime configuration. So what that says is A1 sort of can spread about half of the typical transmission rate to A2 and half of the typical transmission rate to B1, but none to B2 because they don't have any interaction within either day or night. And as you go across the rows of the matrix, you can see how the transmission can spread amongst these four individuals. Next slide, please. And so we can do what's called a lumped model, and the lumped model basically assumes that everyone is actually interacting together. So we don't take into account the fact that A1 doesn't see B2 at all, and we average out the transmission rates. And so you can see a small equation there at the top, but if we had our actual transmission rate was 2, then we get the red curve from our lump model as shown, and if the actual transmission rate is 3, you could see that the the pandemic is progressing faster due to that rate of 3. And this is assuming that we don't know anything about how these people interact, but we've made an estimate based on the average of the interactions. We go to the next slide, please. However, if we know exactly how they interact, so the discussion here before, which is that A1 and B1 work together, A2 and B2 interact in the same community, A1 and A2 are in the same household as the B1 and B2, and we then know that A1 is infected, then we can very carefully model the spread of the disease, and you get the actual transmission, which looks like the blue curve there. So you can see actually that even for both of our transmission scenarios, R0 equals 2 and R0 equals 3, that actually the spread of the pandemic is much faster than the lump model indicates. So that means we're getting a lot of information about how the model spreads by knowing how these individuals interact. The big problem with that is knowing how they interact is going to have a breach of those individuals' privacy. So if we go to the next slide, please. So we're just going to zoom in now to the square indicated with the green dashes. Next slide, please. So now what we've done is we've done a PETS model, and this now assumes that we know something about the interactions of the people, but we don't know who was infected. So we know that one of them was infected, but we're not sure who it was. And then we run forward with the model. So that means we know about the dynamics of how these people interact, but we don't know anything about them individually. So this is the idea of pets. So now we know something about how they're connected, but we don't breach their privacy at all. And if we do this, then you see we get the green curve. And so that's actually closer to what happened in real life. And a much better approximation of what happened in real life than the red curve, which is our lumped approximation. So now PETS has given us the advantage of we've not breached people's privacy, but we've also got a more accurate idea of what's happening with the spread of the disease. Next slide, please. And just to finish up, even if there's a little bit of noise introduced in that model, so the, I'm going to say the mustard or orange curve shown there is a similar model to the PETS model, but I've made it a little bit imperfect by introducing a little bit of noise into the transmission rates. And even if we're not getting an exact representation of how the people interact, still having some idea of how they interact is much better than putting them all into a single model where we're assuming they all interact and then trying to estimate the effect of those interactions by a simple multiplier. So the lumped model is less accurate than even a slightly inaccurate PETS model. So it really shows the value of PETS in terms of getting an estimate of the interactions, even if the estimate maybe have a little bit of noise in its calculation. So in terms of the pandemic resilience project, we're working to build those curves, and if we also had some PETS models working with some private data, we could make those estimates much more accurate and also preserve the privacy of the people whose data we'd be using. And that's all from me. So thank you. I'm happy to take questions on it later, but now I'm going to pass over to our next speaker.
Thanks so much, Mike. Adi, do you want to come up?
Okay, great. Good morning, everyone. My name is Adiraj from the Singapore IMDA. It's a pleasure to be at GPAI Summit in Japan. Japan is very popular among Singaporeans for work and play, so it's great to be here in person, and thanks for the hospitality. In the next 10 minutes, we want to walk you through what we have understood about pets from a business and use case standpoint. I will leave out some details for the panel discussion and give you an overview of what we are thinking about at the IMDA regarding pets and contributing to the pandemic modeling GPAI use case. So earlier this year, our Minister for Communication and Information, Ms. Josephine Teo, launched a program that we call the PET Sandbox. And the spirit of that sandbox was there are a few unknowns about how pets exactly add value to the economy, to businesses, to people. And it was our conviction that we'll learn more by getting hands-on experience, and the regulator will be at the table with the industry partners to do small contained experiments and learn those lessons. So essentially 3 points that I want to walk you through. It's quite apparent, not only to us, but a lot of businesses and people and governments, that it's just getting harder for data to flow from its original environment to a new environment. It happens between business units for multinational companies. It happens from government to business, the business to government. And there are many reasons. Some are regulatory restrictions or regulatory requirements, but there are also proprietary concerns. There may not be any PII involved, and yet a business may think that I may have something to lose in terms of competition if I were to disclose my data in its original form. And I can speak for myself that as an individual, I only grow more wary of where I put my email address, my phone number. So it's our view that in order for the data economy to thrive, there needs to be some test driving of new solutions, and including one of them will be pets. So quick illustration, there are many kinds of pets. I just want to make you walk through just one illustration. So let's say the use case is there are 3 of us in an organization and we want to get a figure of our average salary. So in a world where everybody trusts each other and data flows freely, the 3 of us tell each other our salaries and they would divide by 3 and we get the average. However, in the real world, the salary cannot be disclosed to each other and nor to a third party. So how do we do that? So here's how the PET solution works. This is just one. It's called multi-party computing. Essentially, it splits the data into random parts. So B's salary is 200. It randomly splits it into -80 plus 100 plus 180. And then those split parts are then shredded to trusted nodes. And those trusted nodes can be A, B, and C, their own environments, their own laptops, their own clouds. And the distributed parts, the split and shredded parts, are individually calculated for their average, which gives you an average at node A of -10, B 160, node C 50. And when you sum them up, you get the value of 200. So what exactly happened here is, without A, B, or C finding out each other's actual exact salary figure, they managed to calculate the average, and the data in its original form did not leave its original environment. Just one of the many beautiful techniques of pets. Now, coming to the business viewpoint and the use case viewpoint, OECD commissioned a study along with a research center in MIT to investigate, all right, what's holding back pets? Which pets are mature, which are not, what are the use cases? And it turns out there is a subset of pets that are more mature, they are more operational, whether it's in big tech companies or otherwise. However, there is still a differing view on what exactly people mean by pets, depending on who you ask, which regulator you ask, and they have different definitions, which is perfectly fine. It was Singapore IMD's approach to be less concerned with definitions and more concerned with what exactly happens under the hood. So here's how we simply understood it from a business standpoint. There are 2 types of pets. The orange type that you see there, and during the panel discussion, we can go into examples. There, the data set is not disclosed, the data set still flows, but not in its original form. And I can take an example during the panel discussion later. And the second type of pets, which people may have heard of, federated learning, multi-party computing, is where instead of bringing the data to the code comes to the data. So for instance, the example that I walk you through, the data did not move to a central party to compute the average. It was the multi-party computing code that went to the 3 sources, shredded and split the data, and calculated the average. The basic principle is that data is not disclosed in its original form. At least that's our developing view, and we intend to refine it along the way. Now, the state of adoption is a bit mixed. In the big tech, your Googles and Metas and Microsoft, they have been using and applying and innovating with pets for the longest time, but adoption is a bit slow outside of that sector. Back in Singapore, we have a few research institutes who have done excellent work that has been recognized globally on pets. There is initial nascent exploration among businesses, and I'll later talk about what use cases have we seen in our PET sandbox. And of course, our collaboration under the ambit of GPAI to have pets contribute to refinement of pandemic resilience models. If you may recall, my colleague Mike Mike O'Sullivan, he mentioned that the intent is that we create standard global parameters. So the modelers are not really looking to exchange each other's data, but they're just trying to refine parameters. They are trying to flow insights instead of the data itself. One of the design features in our PET Sandbox program, which I mentioned earlier, was that let's keep the use cases computationally simple, but yet impactful and valuable. And when we consulted the industry, we landed on 3 computationally simple use cases. So in the audience, among those who are coders and programmers, you'll know that this is less than half a page of Python code. So the first use case was, we are organization A and B, and all we need to know is just basic parameters of our common users, our common clients, our common accounts. Use case type 2 that we identified in our industry consultations was, I understand 3 things about a particular set of clients or consumers, and my data source partner understands 3 other things. Can we put those 3 plus 3 things together in a data model and just have a better understanding of that same set of users, customers, clients? So that's enriching a data model by just adding more features. Forgive me for the technical jargon, I'm trying to reduce that in my presentation. And the last use case that we found quite abundantly in our consultations and in our applications is, there is an AI system, and then there's a data source. How do you bridge that gap? Because in order to test the performance of an AI model, you need data. In order to train an AI model, you need data. I'm almost at the end of my presentation. For the PET Sandbox, we identified there are 2 things that are holding back adoption outside of the big tech sector. First is, there are so many PET solutions out there. No one's the wiser on which PET solution works for which use case. So our conviction is that the more experiments we do, the more we'll understand that use case parameters about data flow, the rate of data flow, the amount of data, the data governance laws, how they apply, and does that give us a hint of whether we should use homomorphic encryption or federated learning or multi-party computing. For the Singapore IMDA, we want to develop that know-how. And the second challenge is, what does the regulator have to say? What is the policy position of a regulator when it comes to using pets? Are there compliance requirements? Are there additional requirements? Are there exemptions? There's a concerted effort, not only in Singapore, but in many other countries, to have a clearer policy position, and that's our intention for next year as well. And finally, to wrap things up, this is a lot of detail, which can be found on our PET Sandbox website as well, but we're welcoming Singapore companies to apply for PET Sandbox, and what IMDA gives the companies in return is up to 50% of grant support and regulatory guidance. Perhaps I should mention here, one of the design features that we chose for our program was, we want to limit each project to no more than 6 months, because we wanted it to focus on translation of pets rather than on research of new pets. And with that, if you prefer, you can scan that QR code to learn more about our program. And just a little plug for Asia Tech Exchange, which will come to Singapore, which will be hosted in Singapore next year in June. And thank you for your time.
Fantastic. Thanks so much, Adi. Do you want to come up, actually? So we'll get into the panel discussion now. Oh, yeah, sure. Fantastic. Well, those were a couple of really great presentations. So we've got a bit of time now to get into some discussion. We've got some questions to get things going, and then, yeah, keen to hear some questions from the audience as well. So first question we've got is about the practical dimension of this project, and sort of why the project set a practical demonstration of pets as a deliverable. And what does such a demonstration offer from what is already available? So I don't know, perhaps Shamik or Kim as co-lead, sort of the the folks who kind of originally drafted the concept note. Would you perhaps like to talk about that aspect?
Kim, did you want to go first?
Go ahead.
Okay. Yeah, so maybe I'll just reframe this question. I know it is saying it is a practical demonstration of pets, but really it's a practical demonstration of the value of pets in a real life problem. And that's a better way of answering this question. So there are any number of large companies as well as non-large company scenarios where pets have been used. The issue has not been that pets are not understood, although that is a part of a problem. It's that the value of pets in the context of complex projects which are not within the remit of a single company is more difficult to prove. And that's what I think we were focusing on. How can pets help in these real life situations? Kim, I don't know if you want to add something.
Yeah, I just think that the only thing I would add is what Adi already kind of referred to, which is the practical guidance part, because it is partly about understanding where pets will work, but also then helping to decide which one is the right one under what circumstance, and to have that sort of understanding of how best to implement and use the technologies in real life situations.
Thank you both. I don't know if either Ati or Wansi, if you wanted to add anything as well, or.
I think Shamik and Kim already said quite a bit. Maybe just to contextualize what Adi presented in terms of what the Singapore government is doing, and then how then are we supporting the work that's in GPAI, right, regarding the pandemic response, as well as any other use cases that are coming up out from the work group. I think for us, it's really important, as Shamik and Kim mentioned, that we understand what are the practical issues when working with pets for AI projects. What are some of the legal considerations that we have to take in, especially when we are operating across jurisdictions. It's not just in Singapore. The project is meant to be across different countries. So there are regulatory concerns that we have to look into. And so one of the things that we want to understand are what are the regulatory bounds. And then the other thing that we are hoping to get out of this project, together with the PD Sandbox that Adi mentioned in Singapore, it's really understanding where are the technical limits for pets. There's a lot of literature. We've been working quite closely with the OECD to share and also to learn some of the developments in pets. But I think it's really important that we get our hands dirty and actually really get into what are some of the technical issues. So then we can, and we hope that at the end we can publish then what are the technical bounds as well as the legal and jurisdictional bounds, regulatory bounds that will be useful for not just the Singapore government, Singapore companies, but also other jurisdictions around the world as well as companies around the world.
Thank you so much. I thought as well it might be quite good actually to ask a couple of questions about the search for the right use cases. That was quite a big effort for us this year as well. So obviously we cast the net quite widely initially across climate action and pandemic resilience and the future of work. But I thought perhaps if we could hear a bit about how we landed on pandemic resilience as being the right use case, and also I guess any learnings as well, because there's a few different players sort of searching for use cases as well in this space, and I thought perhaps it might be quite good to share some of the things we learned along the way. So I don't know who on the panel might like to kick off with that.
Maybe Adi can do that since he was really on the ground, right? Talking to all the different use cases from around the world. So Adi, over to you.
Thanks. So quite honestly, the search for a credible use case where we can demonstrate pets making data available for AI, for social good, like pandemic modeling, was rather difficult. A few parameters need to be established in order to understand whether a use case is ready to experiment with pets or not. One is the data barrier needs to be quite compelling. It is often perceived that there's a data barrier because there's a presumption that, oh, if only I have more data, I can do more. That may not necessarily be the case. So one of the tighter assessments that we did in our search for use cases was to establish what exactly is the nature of the data barrier. So in the case of pandemic resilience, It's a matter of sometimes it could involve medical data, or it could involve data of people's location, which can be quite both politically sensitive as well as socially sensitive. So that was one, establishing the data barrier. Number two was the readiness of the AI model. Oftentimes, there is perhaps an idea that, yes, we want to use AI for a certain end in mind, but there is a fair bit of engineering and project work required in order to establish whether that AI model is actually going to fulfill the use case or not. So we also had to filter out a few use cases depending on the readiness of the AI model. And of course, as soon as they are ready, so there were some use cases that we kind of deprioritized, that as soon as your AI model is more or less ready, at least the technical specifications are ready, then yes, there's a possible application of pets. So mainly those two, data barrier and the readiness of the AI model.
Maybe I can add like one more as well. I think it's also whether we can actually have access to the data that we're interested in order to be able to demonstrate its usefulness through pets for the AI project. This means, having the relevant authority holding the data, be able to say, I'm prepared to share this data for this use case through pets. So those are the few things that we needed to come together in order to be able to identify the relevant use case.
Thank you so much. I don't know if anybody else on the panel wanted to add anything on that. That's quite a complete answer. Thank you. So I guess then sort of perhaps Mike might want to come on this one. Are there sort of and others as well, but are there particular existing use cases you've kind of seen out in the wild as well that you've found particularly interesting, or sort of been able to like show some of the benefits? I know, Shamik, we met a few interesting startups as well in Zurich, but
I was going to say I can take this unless Kim wants to jump in. For me, it's been looking at government data sets and getting potential learnings across the world. So some of the work I've been doing is on surgical scheduling and particularly the estimate of durations of surgeries. And so you don't want that health data for individuals to go across the world, but you might be able to get learning. So using a federated learning approach, I think would be quite appropriate there. You could get some models, multiple models across the world about the surgical durations, and then maybe pull them together so that things like maybe it's a hip replacement, that's not going to breach your own privacy, but that's something that would be common across the world. And so I think you can get quite nice learnings with surgical data or medical procedure data using pets to make sure that individual health data doesn't go offshore, essentially.
Thanks so much. Mansi, do you want to mention one?
I think when we were looking at the GPAI use cases, one of the criteria was that it has to be something that's for social good, right? That's why we landed with pandemic response. That's why we were looking at the healthcare use cases and even climate change as a potential use case. I think those were things that we were looking at, municipal services and so on. I think in terms of what are the use cases out there in the wild, as Adi presented earlier, there are some typical use case archetypes. And a lot of these use cases, and the reason why we did the PD sandbox in Singapore is also because we want to get companies, and these are business use cases, so a little bit different from the social good type, business use cases to sort of demonstrate the value that pets can bring, not just to the businesses, but eventually to the customers and the consumers as well. And I think maybe for this audience, some of the interesting ones would be access to data from across different countries within the organization. So that's something that came up quite a bit. And I think that's where also we are hoping to work with other governments to look at some of the regulatory issues. Because here we have the regulator from Singapore, which is the Personal Data Protection Commission, prepared to lean forward and really give the necessary support to the projects. But when we work with use cases from around the world, actually, then we need the regulator at the other end as well to work with us. So I think these are some opportunities that we see for use cases out there in the wild. Yeah.
Thanks so much. So next question is just actually about the benefits, and then we'll hand over for questions as well from the audience. So there's some discussion about pets as to whether whether it's principally about privacy, and I think there's a question about if there's other rights as well that pets could help strengthen. So I don't know, Kim, perhaps you might want to comment a little bit on that.
Yeah, I think there's pets have been known as privacy enhancing technologies, but they really, I think we've talked about them being kind of related to partnerships as well, because they actually help people collaborate who might have hesitation about collaborating otherwise. And some of the other things that we can think about, I think Addy really reflected this in his comments about IP protection being something that we can, I mean, it's a different sort of privacy, but it is distinct. We've talked about them as being able to help with data justice if the use of this kind of technology can encourage places or communities that have been hesitant to participate in the data world. And I think that then relates to the use of pets for respecting sovereignty as well. Some of this comes from indigenous sovereignty and the expectation of the rights around that from the United Nations Declaration on the Rights of Indigenous Peoples, but it can also come in the form of company, community, and territorial or nation state sovereignty as well. And when I'm in Canada, and within Canada, we have a lot of issues with protection of sovereignty across provinces and territories as well. So pets can help in all of these cases through either of the ways that Addy talked about, either the way we share data into pet technology or the fact that the data actually themselves can stay where they are.
Thanks so much. Thanks, Kim. Addy?
Yeah, Kim makes a really good point. There are many more motivations to try pets. Perhaps I'll urge the audience, both virtually and present here, to think of pets as a new way of data sharing, and I put sharing in quotes. The traditional data sharing presumes, or data access presumes that there is trust. So people establish trust either, well, you and I are natural partners, whether it's G2G, G2B, or we create a long contractual document and we create audit trails to ensure that you are committing to the terms that we have established in order to build trust. Pets seems to have a potential to not rely so much on trust and contracts and legal kind of audit trails, and to hard code programmatically permissions. So for instance, if there are issues around IP, some models are proprietary, some data models are proprietary, some AI models are proprietary, how does one ensure that the AI model is being used for that specific purpose? Pets provides an option to potentially hard code and programmatically control the permissions, which kind of reduces the dependency on establishing trust and legal contracts. Surely we still need contracts and understanding and a little bit of trust, but it just reduces the burden to get things started. It's my view on pets.
Thanks so much. Are there any questions as well from the audience? Oh, yep, there we go. I think your mic's coming your way. Just say who you are and where you're from as well, please. That'd be great.
Testing? Does that work?
Yep,
okay,
we hear you.
Perfect. Thank you for the excellent presentation. From my experience, some of the major blockers to pets is one, a lot of them are not very generalizable, so that makes them extremely expensive to build, and that means also that there are not enough experts in the world to address pets for every use case that comes up. So if your sandbox it works out and you find really good examples of uses of pets, is there a second step where either there will be a focus on generalizability or on workforce education?
Thank you for the question. Sorry, maybe we can get your name and where you're from.
Yes, Patricia Thane. I'm from Canada, and I'm part of Private AI.
Definitely, I think the sandbox is, as Adi mentioned, is meant to be sort of our first push to get industry, to get companies to try pets a little bit more. POC, 6 months. After that, what we want to do is two things. Number one, publish some of these learnings, use cases, what are, as I mentioned earlier, the technical as well as the regulatory boundaries that we're trying to push. For the regulator also to be a bit more specific about what is acceptable from the legal perspective in terms of the use of pets. So for example, we're talking about differential privacy, then what kind of epsilon number is useful, for example, right? So these are things that we are hoping to do as the first step of the sandbox. Then the next step then is to identify where are the gaps, both in the technology as well as in the ecosystem that we have to address as a government. So we're not just a regulator, we are also an ecosystem developer. So we look at talent, we look at infrastructure, we look at other capabilities that we have to enable in the ecosystem. So these are things that we want to identify. And then we say, are we ready for a broader push for generalized pets? Do we need to drive more research investment in specific areas to do that? Do we need to encourage more capability development at the talent level? That means the professional level. Do we need a common infrastructure, around NPC, for example, if that makes sense, right? So I think these are things that we have to figure out. I don't think we'll get it done by June of next year, which is really our target for the first sort of sharing of where we are with the projects. But certainly these are steps that we can take or that we plan to take eventually. Thank you.
Thank you. Any further questions from anybody in the audience? Okay, well, I have one more as well up my sleeve. So I was going to ask a bit about risks as well. Any of those that we should be thinking about when we think about potential guidance in future on this? And yeah, be keen to hear your thoughts on that too, so we're being balanced.
Maybe I can start off with that, if that's okay. I think the biggest, as you were speaking about the benefits of pets, all of us were speaking about it. If you were not aware of what we were talking about and replace the word pets with blockchain, almost everything you said would have been true. And the reason I quote that is to say that the biggest risk is actually non-adoption of pets and the lack of, the missing out on the opportunity, particularly for entities other than large companies, which do sit on a lot of data. Except for those, everybody else, whether it's civil society, governments, smaller companies, etc., the biggest risk is actually that all of them will be unable to get the full benefit of leveraging data. And the reason I use blockchain is of course that many of the same arguments have been made for it. I don't mean crypto, I mean specifically blockchain. And over time, it's been very difficult to actually capture some of those benefits. So I would see that is the biggest risk, which is how do we make sure that the promise from these set of technologies, not from one of them, but from this set of technologies, does not remain unproven and untapped, would be my sense.
Thanks, Shamik. Anybody else on the panel want to add to that? Or? Okay.
If I may.
I think it. Oh.
Yeah, Mike?
Go ahead, Mike. Yeah, sorry, yeah, I think for me, the biggest risk is losing that trust. So at the moment, people are providing their data in a way that they're confident is going to be taken care of. And so if PETS is not done well and people think their data is not going to be, their private data is not going to be taken care of, then they may stop contributing that data. And I think that will be a real loss. So that's why I think it goes back to sovereignty that Kim talked about. I think they're entrusting us with their data, but they want to keep control of it. And I think we need to make sure we do that in our PETS approaches.
Thanks, Mike. Adi?
Yeah, I kind of, again, forgive me for any kind of technical jargon. Oftentimes, the risks boil down to the use case details. So for instance, in the case of differential privacy, in simple English, it adds a little bit of noise so that it's not exactly the same data set, but it retains its large statistical properties. But there's a downside to differential privacy that if I keep making inquiries on that data, I could potentially reverse engineer it. And similarly, there's a risk for other PET techniques as well, which is why, and I want to tie this back to the question earlier from our colleague from Canada. I urge our partners to take a use case centric approach. This is exactly what we did for the GPAI project. This is what we're doing for the PT Sandbox project. If you take a use case centric approach, it is our belief that one is that you have a better understanding of which use case will apply a PET solution or a stack of PETs at scale, so that you can have a more generalized PETs. That's one. And the other is you will have a clearer understanding of, for this use case, if I use these PETs, these are the risks which I need to engineer for. And I trust that the engineers will address those risks accordingly. But if we take a PET-centric approach that, hey, I want to create redundancy so that my differential privacy solution is absolutely no risk, that's a harder problem. That's a harder approach to pin down.
Thanks so much, Adi. So I think we're coming up to the hour now. So that's been really interesting discussion. I hope everybody here and also watching at home has found that interesting. And I think very keen, if you want to continue the conversation, to come up and say hi. I'd like to sort of just say a quick thanks to all of the panel. I'd also really like to say a big thank you as well to Stephanie King as well. He's over there, and just he's been a really fantastic project manager on this from Semir. He's helped really take it forward to this new exciting phase of us just getting started with the practical demonstration as well. So a big thank you to Stephanie too. So with that, I think thanks everyone for joining us, and I'll hand back over to Mike, who I think is going to give us a traditional farewell as well.
Yeah, thanks, Ed. If I can get that slide up. So this is just to close off the meeting, to allow you to, I guess, free your thoughts to move on to whatever's come out next for you. Can I grab that slide, please? Unihia, ki te uru tapanui, ki watia, ki mama, te nako, te tinana, te wairua I te ara takata. Koe ara I rongo, pakairia ake ke runga. Kia tina, huie tai kia. Ngā mihi everyone.
Fantastic. Thank you so much, everyone. Thank you.
Thank you.